Today we are going to look at the method of long division. But before then, I need to say this, that shortcuts are good. Hacks, I love them. I also use them a lot. But a child must be given the prerequisite foundation before these shortcuts and hacks are introduced. Okay, imagine a scenario where a child walks into an examination hall and behold, there's a question, use the method of long division to solve the show walking. The child fails from the spot. Why? Because before that exam, perhaps he or she was only introduced to a shortcut or a hack that would enable the person or the child arrive at the answer without showing the steps. The same thing is applicable to those of us taking mathematics and further mathematics in the senior secondary. We have seen a lot of things. Take, for example, the method of, or there's the topic quadratic equations. There's a method which we call the method of completing the square. We even use that method to derive the general formula used to solve quadratic equations. If you just go try with your students, tell them, use the method of completing the square to solve this equation. See how many of them are going home with zero scores. So there is need to take time and lay the foundation in our kids before we introduce shortcuts. This is a generation that loves shortcut. They just want the easy way out. But sometimes we can't just let them have their way. So let's take time and build within them the foundations they need so that it will really help them tomorrow. I hope I have simply said something. Okay. Now here we are 56 divided by 3. 56 here is the dividend, while 3 is a divisor. So we will put it in our box. Okay. We build a little house. We take question number 1 first. Build a little house. 56 will go inside. 3 will stay outside. We start our work. The first digit here is 5. Don't forget the place value of 5 here is 510, 66 units. So we are taking the first digit here, 5. But if the first digit here is less than the divisor, that is when we consider the first 2 digits at once, okay? So here 5 is greater than this, so we can use that. Even if 5 were to be, the first digit rather were to be equals to 3, we will still use that method. So we ask ourselves, 3 goes into 5, or 5 divided by 3, what will you have? We are not interested in the remainder. Or ask yourself, 3 times what will give you 5, or the closest number to 5. You see, 3 times 1 will give you 3. 3 times 2 is 6, which is greater, okay? The same thing, if you say 5 divided by 3, you are going to have 1 remainder. So it is that one whole that we look for. So we say 3 goes into 5, we can say 1. 1 times 3, that will give us 3. Please, I want you to know, because we had used the first digit here, whose place value is tens. This 3 is not 3 units, but 3 tens. And what's 3 tens? It's the same thing as saying 30. So we can do that. I know some persons leave this place blank, okay? But just know that it is 3 tens. So we subtract from here 6 minus 0, 6. 5 minus 3, 2. We'll repeat that process, okay? 3 goes into 26, or 26 divided by 3. What will you have? Or 3 times what will give you 26, or a number closest to 26. It must not be greater than 26. You see where the multiplication tables are very important. So it's going to be 8, okay? We have 8. 8 times 3, 24. We minus again. 6 minus 4, 2. Okay? 2 minus this, 0 is gone. So we end up having 2. Okay? We repeat the word. 3 goes into 2. Here now, the dividend is less than the divisor. In other words, we cannot bring out 3 things from 2 things. We cannot. Ordinarily, anyway. So 3 goes into 2 cannot, because 2 is smaller than 3. What we do is to come up here, put a decimal point, come down to 2 and add 0. It becomes 20. Have you seen that? 3 goes into 20. 3 times what will give you 20, or a number closest to 20, must not be greater than 20. That's 3 times 6. Okay? 3 times 6. 6 times 3, 18. Okay? We repeat it again. You know, here, 20 minus this will still give you 2. You realize that we'll continue to have a repeated decimal. 6, 6, 6, 6, 6 to as many places as possible, okay? So we can do it here and stop here. 3 goes into 2, cannot, we add 0 again. So 3 goes into 20, that becomes 6 again, okay? So we can stop at this stage without going any further. We can express our answer maybe to 2, 3 decimal places, knowing fully well that the fractional part will continue repeatedly to no end. So we can simply say the answer here will be what? The answer here, the answer here will be 18.67. If I want to express my answer to 2 decimal places, I can do that, okay? So that's for that one. Now we'll pick the second one, which is 78 divided by the number 12. So let's see. 78 for number 2. We'll put 78 inside. It is the dividend. And 12 will be what outside? Remember, in this case now, the first digit here is 7, while the dividend here, sorry, the divisor is 12. So 7 is less than 12. So we are considering the two digits at once. Okay? Because the first digit here, 7, is less than the divisor, which is 12. Alright, so 78 divided by 12. What do we have? 12 times what will give you 78, or a number closest to 78. You see, it's going to be 6. Okay? Because 6 times 12 is 72. So we subtract 8 minus 2. What do we have there? 6. 7 minus 7. Okay, that's 0. So we repeat the process. 12 goes into 6. Here, the dividend is less than the divisor. So what do? We come up here, fix a decimal point, and then add 0 here. Becomes 60. 12 goes into 60. 12 times what will give you 60, or a number closest to 60. It must not be bigger than 60. So 12 times 5. From our tables, 5 times 12, 60. Okay? If you subtract that, 60 minus 60 is gone. We end up having 0. So what does that tell us? The result is what? 6.5. Okay, so 78 divided by 2 gives you 6.5. I'd like you to try your hands on question number 3. Okay, try your hands on that. Use the method of long division. Drop your solutions in the comment section. Feel free to like, share, and also reach out to us if you have any concerns. Let me repeat, if you've not clicked the follow button yet, please do so to encourage us, and tag people, friends, those you know will benefit from our videos. Thank you.